Look over to the sideboard here. Algebra 1 on Married Monday, the 21st of September. That ain't one, okay? SBA students will be able to solve equations with variables on both sides. Section 2.6, okay? Heads up. Thursday, we're going to be quizzing over 2.4 to 2.6. Thursday, we're going to be quizzing 2.4 to 2.6, okay? So just a friendly notice on that Thursday we're going to take a quiz over 2.4, 2.5, and 2.6, okay? And then we'll do a lesson. And heads up, our test is going to be next Wednesday, okay? Just a heads up on this kind of stuff coming up. Yes, this was a fast chapter. Alrighty, so variables on each side. So to solve equations with variables on each side, we're going to rewrite the equation so all the variables are on one side. So our first step we're going to do is to put all the variables together, okay? There's a couple ways we can actually do these, but we're going to try to make a habit of this being our first way, just because I found that it's typically the most straightforward way for us to think about it. For most people, it's the easiest way to think about it. So we're asked to solve the equation and check our solution. Number 1, 8 plus 5s equals 7s minus 2. So how many s's do we see here? 2. Now we've seen two of the same variable before. We saw them on our warm-up. We saw them on the homework we just turned in. But we saw them on the same side of the equal sign. You guys remember how I say left side, right side a lot? Yeah. I'm always talking about the equal sign, where it is compared to the equal sign. So here now we have a 5s on the left, a 7s on the right. What we're going to want to do is we're going to want to move one of them to where they're with each other. Now, how do we move things across the equal sign? We always do the opposite sign, right, to move it across the equal sign. Okay, so how would I move 5s if I wanted to move the 5s? Emily? I'd subtract 5, okay? I'd subtract 5 from here and here, on the left and the right. How would I move 7s if I wanted to move that? Subtract it. So we really could move either. Now, we have to ask ourselves this question. What would we rather do? Would we rather subtract 5s on both sides and have s on the right? And what would 7 minus 5 be? 2. Would you rather have a positive 2s on the right-hand side? Or other option would be to subtract 7s on both sides. That would create a negative s, wouldn't it? That'd create a negative 2s, and it'd be on the left. So we ask ourselves, what would we rather do? Have a positive or a negative s? Positive. Typically, we much prefer dealing with positives. So would you rather that we subtract 7s or subtract 5s from both sides? Let's subtract 5s from both sides. So let's move all the s's to the right-hand side. So we'll subtract 5s on both sides.
What about 8?
We'll leave it there for now. We say, okay, did 8 change at all?
No.
Nope, so we'll just keep writing it. Okay, what's 5s minus 5s? 0. So I'm going to those 0 out. I don't have to write plus 0. Then I can put my equal sign. I'm just going left to right in order. What's 7s minus 5s? 2s. And I still have my negative 2. So I have 8 equals 2s minus 2. So does this just turn into a two-step equation?
Yes, sir.
Yeah. Our first step was to get all our variables together. Now we got all of our variables together on the right-hand side. We're going to want to move all the constants away from the variable. We're going to move the constants to the other side. So how do I get rid of that negative 2? By adding 2. Yes. What's 8 plus 2, Ellie? What's 8 plus 2? 10. Nailed it. 10 equals 2s, and negative 2 plus 2 is 0. Isaac, what would we do now? Divide by 2. And what's s, Isaac? But what is 10 divided by 2? What does s equal? 5. S is equal to 5. Don't confuse it as 5 equals 5 or s equals s. One's a 5, one's an s. Yes.
Would it be the same thing if we did that?
On the other side? Great question. Would we get the same thing if we subtracted 7s to start with instead? Well, let me work through that real quick. Okay, I'm not going to make you guys work through that, but let me work through that real quickly. So let me write the equation. Start by subtracting 7s. I have 8 minus 2s equals negative 2. Well, now I subtract 8 to get rid of a positive 8. Negative 2s equals negative 10. I divided by negative 2. S is equal to, what's negative 10 divided by negative 2? 5. So S does end up being the same thing regardless of what we started with, right? So it doesn't matter which way we move our S's to, which way we move our variables. But typically, we're going to prefer keeping them positive when we can. Okay? You won't always have that option, but we're typically going to prefer keeping them positive, okay? All right, it did ask us to check our work. So how do we check our work?
Plug it in.
Plug it in, right? We do math. We plug it in. Okay, now where do I plug in my 5 to? Do I plug it in on the left or the right? Both. It's a trick question. I plug it into both. 8 plus 5 times 5 equals 7 times 5 minus 2. You should replace the S's with the 5. Well, 5 times 5 is 25. Ha ha ha. 8 plus 25 equals 30 minus 2. Well, what is 8 plus... Excuse me, not 30 minus 2. 35 minus 2. 7 times 5 is 35. I goofed up. What is 8 plus 25?
32.
30, try it again. 3. What is 35 minus 2?
33.
Does 33 equal 33? Check. It checked out just fine. Questions on number 1. Alrighty. I want you guys, I'm going to erase part of this now. Okay, if you guys have it, raise your hand if you still need that in green. Okay, I'm going to erase that just so we can see what's happening there. I want you guys to try number 2 on your own. And when you have it or have questions, raise your hand. Try number 2 now on your own. When you have it or have questions, raise your hand. 3W plus 2 equals 7W. From what I saw, for the most part, we chose to subtract 3W from both sides. Okay, we could subtract 7W if we wanted, but most of us chose to subtract 3W, and that's what I would do. Let's keep our W's positive, okay? So 3W minus itself is 0. We don't have any more W's, okay? We would really have 0 times W, but what is 0 times anything? 0, so I don't need to write that. So I just have 2 equals 7 minus 3 is 4W. When I get to this point, a couple of us got slipped up after we divided by 4. We said 2 divided by 4. Some of us call that 2, but we got to be careful. What goes into both 2 and 4? 2. And it goes into the top how many times? Once, and the bottom how many times? Twice. So it's really 1/2 equals W. 1/2 equals W, okay? Or 0.5 in decimal. Okay, or 0.5 in decimal. Okay? Questions on that? Alrighty. Let's look at number 3. 1/2 S plus 1 equals 1/4 S minus 3. Now, we said that we like to try and move the smaller one across to keep it positive, right? We moved the 5S across, it was smaller, kept it positive. We moved the 3W across, it was smaller, kept it positive. Well, here, I'd get rid of a positive 1/2 S by subtracting it. I'd get rid of a 1/4 S by subtracting it because they're both positive. Which one of these would I rather move to the other side? Which one of these would I rather subtract by? 1/2 S or 1/4 S, Elijah?
1/2.
Okay, I'm actually going to disagree with you, okay? Because we want to do the smaller one. Let me ask this. What would you guys rather have? Half a pizza or a fourth of a pizza?
Half.
Probably half pizza. Why?
Because I'm hungry.
Because you're hungry and it is more. It's more. Okay? But it's more of the pizza. So a half is more than a fourth, even though 4 is more than 2.
No one likes leftovers.
That's not true.
I do.
Leftover pizza slaps.
No, it's not.
McDonald's pizza sucks.
All right, automatic F. Okay, so we would rather subtract the 1/4 S from both sides. Now, what am I going to need to do here with these denominators? But first, we can just write it if you want. 1/2 S minus 1/4 S plus 1 equals a 1/4 S minus itself is 0, negative 6. So we can go ahead and write that, though. I'm going to ask you guys to finish this off from here. All right, continuing on. 1/2 S minus 1/4 S, our common denominator is 4 that I saw, okay? So we have to multiply this one by 2 and 2. So we end up getting 2/4 S minus 1/4 S plus 1 equals negative 6. Well, 2/4 minus 1/4, we end up getting as 1/4 s plus 1 equals -6. Subtract the 1. 1/4 s equals -7. Now, when we're multiplying by 1/4, okay, we have to end up dividing. But we don't like dividing by a fraction because then we get double-decker fractions. That gets confusing fast. So instead, we multiply by the reciprocal or reciprocal, 4/1, or just 4 on both sides. On the left-hand side, those 4s will reduce, and we're just left with s, which is our goal. On the right-hand side, -7 times 4 is -28. Okay, so it's -20. Let me rewrite that 8. Questions on that one? Alrighty. Give me 1 second to get them started on that one. Alrighty. So we're going to talk about grouping symbols now. Where did the rest of these go? There we go. When solving equations that contain grouping symbols, first use the distributive property to remove them. So 8s minus 10 equals 3 times the quantity of s minus 2s, or 6 minus 2s, excuse me. We'd start by distributing. And then we have the same type of problem we just had. So let's go ahead and distribute this one. What is 3 times 6? 18. Well, first, let me write what's there. 8s minus 10 equals has not changed. 8s minus 10 equals has not changed. 18. Thank you, Jack. And then we do 3 times -2s, which is -6s. Does this now turn into the same type of problem we just had? Yeah, so we have to think, would I rather do the opposite to 8s or do the opposite to -6s? Would I rather subtract 6s or add 6s to both sides? And that's what we have to do. So go ahead and solve this problem. So we can ask ourselves, would we rather subtract? Thank you. Would I rather subtract 8s or add -6s or add 6s? And I think most of us would like to add 6s, okay? You can do either once again. But it might be easiest to get 8s plus 6s is 14s. Keep that positive. But once again, you could do either. I saw some people doing the other way, and you got it right as well, okay? Equals 18 because -6s plus itself is 0. Now, since we got all the variables on the left-hand side, we want to get all the constants on the other. So I'm going to get rid of that -10 by adding 10 to both sides. -10 plus 10 is 0. 14s is equal to 28. So now I divide by 14 to undo multiplication. S is equal to 2. So S is equal to 2. Any questions on that one? Okay. Now, hey guys, I just want to recap something for us, okay? So before, on other problems, let's just say this problem is not in the notes, okay? This problem is not in the notes. This is an extra one I'm just going to pull up real quick for us just to compare, okay? So if I had a problem like this, okay, is that pretty similar to what we just saw? Yeah. Right, all the same numbers and symbols. What's different on this red one? Okay, there is an equal, but they're all on the same side of the equal sign now, right? Okay. Now, how would I combine this 8s and -6s here? What would I get when I combine those here? I get 2s. Now, why did I get 2s up here, but I got 14s down there? Okay, Abby.
You didn't change the -6 to a positive.
Yeah, I didn't change. I didn't add 6s to both sides this time. Why didn't I have to add 6s to both sides? It's right that we don't, but why didn't I here? Abby?
It's on the same side.
Because it's on the same side already of the equal sign. So I have this little saying here to help us remember this, okay? If they're on the same side of the equal sign, we do the same signs as what's there. So because these are both on the left side, they're on the same side, we stick with the same signs as what's there. A positive and a negative will make positive 2s. Whereas these are on different sides of the equal sign, so we do different signs from what's there. We have to say, oh, well, instead of negative, we're going to be adding it. We're going to do a different sign, okay? Does that make sense?
Yes.
Okay, give me a thumbs up if that made sense, thumbs down if it didn't. You can't just not vote. Alrighty. Continuing on, I want you guys to try number 2. The only thing different on number 2 compared to number 1 is we have to double distribute. Okay, so distribute on each side. Thank you. Alrighty. So we start by distributing. 7 times n is 7n. 7 times -1 is -7 equals. -2 times 3 is -6. And negative 2 times n is negative 2n. We ask ourselves a question. Would I rather subtract 7n or add 2n? Haven, what would you rather do? Subtract 7n or add 2n?
I don't know. You tell me.
I don't know. You tell me. You were supposed to do your problem already.
Yeah.
So it shouldn't be an issue.
Subtract 2n.
Okay? Brady, would you rather subtract 7n or add 2n?
Subtract 7n.
You'd rather subtract 7n? Okay, we can do that. If you went a different way, that's perfectly fine. Personally, I would probably rather add the 2n to stay positive, but Brady wanted to subtract it, and that's perfectly fine. We can do it either way. Negative 7 equals negative 6 minus 9n. Both negative, so we add and keep the sign. Now, at this standpoint, even if this isn't what you would have, even if this is not what you had on your paper, we can still solve this. What would I do now? I moved all my n's to the right. Where do I want to move my constants to, Emily?
Add 6.
I want to add 6 to move my constants to the left. So negative 7 plus 6 is a negative 1. There we go. Negative 1 equals negative 9n. Now what do I do, Josh? Not add, but what's negative 9 doing with n? It's multiplying, so we would divide. Yeah. Divide by negative 9. What's negative 1 divided by negative 9? 1 over 9. I saw a lot of us were just writing positive 9 here, okay? Positive like 9 as in like a 9 over 1. It's not the same thing. We just have to leave our fractions as fractions sometimes. That'll really help us, okay? If you just rewrite it, 1 over 9. In the case, negative divided by negative is a positive. Negative 9 divided by negative 9 is n. So I end up getting 1 over n equals 9. Even if you didn't do this way, even if you added 2n to start, did you still get the same answer? Yeah, it doesn't matter which way we went. Okay?
Doesn't matter.
Any questions on number 2? Alrighty. Okay, a couple questions left. No solutions or identity. Some equations, listen up. Some equations may have no solution. This means that there is no value of the variable that will result in a true equation. There's nothing that'll make it true ever. Nothing will work. You can plug in any number you could ever think of. It won't ever work. Other equations are true for all values of the variable. Okay? Other equations are true for all values of the variable. An equation like this is called an identity because it's always true. It's kind of like when we said if we add 0 to something, it's our additive identity, or multiplied 1 by something, it was our multiplicative identity. It didn't change it, okay? It's always true. Meaning, when you have an equation like this, no matter what you plug into, you can think of any number ever, and it would work. Okay, whether that's 0, whether that's 5, whether it's negative 2, whether it's 452.85241, it would work. Okay, literally anything you could ever think of would work in a solution when we have what we call an identity. So we're going to look at a couple of these by solving these equations. 8 times the quantity of 5c minus 2 equals 10 times the quantity of 32 plus 4c. Is this pretty similar to what we just did on our last couple of questions? Yeah, so what are we going to start with here? Distributing. What's 8 times 5c? Okay, and what's 8 times negative 2? Negative 16. Put the equal sign there. We like multiplying by 10. What's 10 times 32? 320. Add on a 0. What's 10 times 4c? 40c. Add on a 0. So now we want to get all of our variables to one side. So what would we do here? Subtract what? 40c from both sides. We might notice something neat here, okay? What's 40c minus itself? 0. Negative 16 equals 320. What is 40c minus itself? 0 again. Wait a second. We got rid of all of our variables. When you get down to an equation like this, where there's no variables, negative 16 equals 320. Is that true? No. So that's one of our no solutions. No solutions, okay?
So we don't even solve for C?
You can't. Or you can also say no SOL. Either one. Okay? When you get down to an equation with no variables, and it is never ever true, negative 16 will never equal 320. It's no solution. That means that no matter what we plug in for C here, it will never work. It's the first type of equation we talked about in our bullet point up here. Okay? It has no solution. Doesn't matter what we plug in. You can think of literally any number. We could be trying all day. You'll never find the answer. Get down to an equation that is not true. Questions on that one? Okay? Let's look at number 2. We're going to start off the same way with distributing. What is 4? Okay, go ahead, Abby. What's up? No, what's up?
No, it's kind
Is it about math?
No.
Okay.
Kind of.
Oh.
Never mind. It doesn't matter.
Is it about the last problem we just did?
No. It's about this problem too.
Okay. Well, we'll distribute 4 times t. What is 4 times t?
14.
What is 4 times 20?
80.
80. Okay, 4t plus 80 equals 1/5 times 20t. 1/5 times 20t. Okay, well, you can think about this. 1/5 times 20 over 1. We're really going to be ending up doing 20 over 5. We're going to divide these by 5, basically, okay?
4.
So we end up getting 4. So we have 4t. And 1/5 of 400 is going to be 80. Okay? So you know that we could also do that off to the side, okay? Or you could say, let's cover up that last 0. 40 divided by 5 is 8. Put the 0 back on. 4t plus 80 equals 4t plus 80. You might notice something here, but let's keep going. We could subtract the 4t. 4t minus itself is 0. 80 equals, well, 4t minus itself is 0 again. 80. We got down to another equation that's just numbers, no variables. What's different about this equation, though? It is true, right? 80 does equal 80. So anytime you get down to an equation with no variables, but it's true, this is our infinitely many solutions. Have you guys heard of IMS before? No? This is new to you?
What does it stand for again?
Okay, great question. It stands for infinitely many solutions. So this is that identity we were talking about. Okay? This just means that no matter what you plug in for t, it's going to work out. You could plug in the most obscure number you could think of, and it's going to work. Okay, or the most basic number you could think of. You could plug in like 1, it'll work. You could plug in negative 392.5, and it'll work. Okay? So when you get down to an equation that's never true, like in the orange, it's no solution. When you get down to an equation that's always true, like in the purple here, it's going to be infinitely many solutions, aka IMS. Now, did anybody notice something in this step here, 4t plus 80 equals 4t plus 80? What did we might notice here?
The same thing.
It's the exact same thing. That's a dead giveaway when you have quite literally, the exact same thing. 4t plus 80, 4t plus 80. Now we're going to have infinitely many solutions. Okay, if you have the exact same thing, nothing is different.
Could you stop there if you want to stop?
You could actually stop here as long as you answer infinitely many solutions. This is your answer, though. Okay, great question. You could stop after this if you wanted. Some of us might want to go a little bit further just to make sure, okay? Okay, any questions on that one besides what's been asked? Okay, so don't panic if you get rid of your variables. It's an okay thing. Good luck. Good job. Okay. Bottom left-hand corner. Don't do numbers 7, 14, and 15.
That's it?
Fine, do them all.
No.
Oh, okay, yeah. Don't do 7, 14, and 15 then.